Hello there and welcome to my workshop. Today we're going to do a Carveco video. It's going to be split up into two parts. The first video is going to be the Carveco video where I take a genuine grayscale image off the internet. I found a beautiful American bald eagle on the internet, so I'm going to take that off the internet and put it into Carveco and treat it in Carveco, clean it up because it always comes in with some noise. I'll show you in a minute. And then we're going to process it in Carveco, do the speeds and feeds and the different tools that we're going to use with a roughing strategy and then a finishing strategy. We might even do two roughing strategies because I plan on doing a big this is going to be a big carving. Okay, here it is. I'm going to be machining this on my large Cnc router because I want to cut this in the X direction, and I can get 600 millimeters across in the X direction, and actually 1200 in the Y. So that's 2 feet across and 4 feet down the table. So you know, this would be the maximum size piece that I could get on my small milling machine, but I think it'll be done better on the large one. So what I've done is, I think this is Canadian actually. This is Western red cedar, and of course this is Tasmanian pine, and I've laminated the two together. If you can see, they were very flat, plain, nice, and you've got to be careful when you get your material from the wood merchant. You know, sight it down, make sure it is nice and flat, because you do pay the extra to have it planed. So I've laminated it together, and so I'll just get an overall size so we know exactly what we're working with. Okay, so this is that, I think it's a bald eagle that I found grayscale on the internet. So this is what we're going to carve, and so it's going to be about 550 in length. I don't really want to go with the 600 because it's going to make this distorted. Highlight, drag, and drop it in. So now what we need to do is to set up our model size. Now the width, I want to make a maximum width of, well, I'm going to make it 580, and it really doesn't matter about this figure for now because I'm going to actually draw a boundary box around our relief. Even putting the Z height, it doesn't really matter at this point. Because I can alter that further on into the process of using the program. But I do know that I want 46 millimeter in Z depth, and we're going to OK that. And let's make it a little bigger. We're going to have to treat this a little. It's a little snowy. In actual fact, I can make it a little brighter. If you want to alter the colorization of this or a different material, you can do it fairly simple just by going to the little lamp up here, which brings this dialog box up. And I just want to turn the ambient light up a little and apply. That's okay, I think. Maybe a little bit more. Yeah, I like that. Can I OK that? Now then, the first thing that we're going to do is, now I can see that in here and around the edges here, you might not be picking it up on the camera very well, but there are noise, imperfections then, that have come in with this grayscale, genuine grayscale relief. So we're going to iron things out a little. We're going to come up here to the smooth relief tool. Now this brings a dialog box up. You have a choice here whether you wanted selected vector or the whole relief. We want to do the whole relief. So you can actually do a segment if you wish. So we're going to go a strength of, we're going to go 5% because I want to keep it nice and crisp. I want this detail as well. So we're going to apply, we'll try a little bit more, just have a look. Yeah, that's a little bit too much. See, we're losing detail. And this is one of the improvements in this program since the earlier ArtCAM programs, that real time you can see exactly what you're doing or what you're changing or manipulating. A little bit less. %, maybe. And that's got rid of all the noise around here. I don't know whether you're picking that up actually, but there was a lot of noise around here, and within the feathers here there was quite a bit of noise, and now it's completely gone. But I want this detail left in here, so I'm going to apply that, and we can get out of that. Let's get the twiddle. Oh yeah, that's going to be really, really nice. Beautiful. Beautiful eagle. Okay, so now what I'm going to do is I'm going to put a boundary box around here because there's going to be a lot of wasted machining time here. So what I'm going to do is go into the 2D and get our drawing tool. So what I'm going to do eventually, when we do the toolpaths, I'm going to tell ArtCAM to machine inside of this vector. So this becomes our boundary layer. In actual fact, I'm going to make it a little bigger. I'm going to take this up to 190. I'm going to take this to I'm going to take this to 200. I take that to 200 because I want to be sure of going machining all the way down through the darker material and just into the pine. So it eliminates all of the darker material, the western red cedar from around here. So the eagle is entirely western red cedar, and then the background then is the pine. I think that's going to suit us just fine there. I'm going to say create. So that now becomes our boundary layer. Let me just go to the 3D. And that's fine. Our start point of our machining is here. So it's not going to come down here off the material and start machining. So now we have treated our image and we're happy with that image. We can start the machining process. Now you can either come here to Toolpaths and bring up the machining dialog box, or we can come up here and do the same thing, 3D and machining. Okay, so not a finishing option. Now I actually separate this up. Now I think we can do this in 2 machining operations. The first is going to be a rough-in. So we select the rough-in, and so we're going to have to make a tool in the tooling list. I've just had a new tool delivered, which is this one. This actually is a bit sticky. It's got like grease on it, a little bit of waxy grease on it, so it's brand new. And this is a extended 1/2 inch actually milling cutter, or a rotor bit, and it's going to be the best type of tool to actually machine this for a rough-in strategy. So we're going to make a new tool. So we're going to choose, and it's actually 12.7 millimeters. So we're going to choose that one, which is 12 millimeters, which is close to it, and we are going to copy it. So we're going to select the one above, which is the copy. Then we're going to go into edit, and we're going to say this is 12.7, which is 1/2 inch. Again, here we're going to go diameter 0.7, because otherwise it could, probably unlikely, but it could actually machine away material, you know, which is going to be that we don't want machined away. Step down. Well, I'm going to say that it's 5 mil. You know, we can change this when we've chosen the tool. We can change this in the next dialog box. This is just what the setup is for the tooling list, so we can choose it. So we're going to OK that, and we've got that one selected, so we're going to select it. That's going to go into here. Now we can change the settings to suit our machining application here. Step over 4.5 millimeter. These are the recommended. Step down 5. Do you know what I'm going to do? I'm going to go 4.5 as a step over, and I'm going to go 4.5 for the step down, and feed rate 42. It's fine. Actually, I could go a little more than that. I could go 50, and I could go 25 here. We're going to do a normal raster with this. We're going to do climb milling, and we're going to do both directions. Yeah, both directions, not climb milling. Oh, that's telling me that's how much it's going to take out. And it's going to leave that material behind. It's going to do it in 11 slices. That's okay. Add ramp moves, absolutely, definitely. You know, you don't use a tool like this and without a ramp move, because if you plunge straight in, if you notice the cutting edge, I'll bring this close to the camera so you can see. There's 2 cutting faces. There's one here and one here, but in the middle is nothing. So if you just allow the tool to go straight down in like that, it's just going to crush the material underneath it here. Okay, because it's not going to be able to cut it away. So you need it to come through sideways like that and cut the material away. That's one of the little tricks using these type of cutters. .10 angle, plunge height. That's okay. Limited length. Wrap length. Oh, I think we need to be a wrap length needs to be, I think, 15 millimeters. No, that's okay. Safe set over the material. No, that's way too much. We only need to be 20. So 20, that's fine. Material setup. I'm going to make that 50. This is all okay. I'm going to okay that. So let's just check back through here. Rough in, and it's a 12.7 millimeter. Okay, and we're going to calculate that. One little thing that I didn't actually alter, and I was done the whole relief. Now what we want is selected vector inside the selected vector. Recalculate. Okay, so having recalculated, that looks a little better. There's no sort of wasted time running the tool here either side. So, you know, it's going to cut the time down by a factor probably about 30%. So I think what we'll do, we'll run that as a, let's have a look and see what it looks like. Simulation, run the toolpath, fast. Okay, let's have a little look with the twiddle. Okay, that's what it's going to look like. And of course these are not going to be there. So that's what the rough-in looks like. So now we're going to do a finishing toolpath. Let's get selected vectors inside. So this time we're going to use my favorite 2mm tapered ball. If that's okay, I'm going to do a step down of 5mm just to make sure that it does cut it all in one. That's okay. This is 25. And we're going to run this at 20,000 RPM. Normal raster. It will still keep the ramp in moves. 20, there's 2, there's 50, that's okay. So this is cut 2. Sea of red. Let's have a look. So let's do there you go. Beautiful eagle. So now we're going to save the toolpaths. So you just come here, save the toolpaths. We're going to browse. We want to save this in removable disk F. There it is there. So we've chose where we want to save it. And it really doesn't matter which one you save first. So this is cut to T. I'm going to say ball mill. Now, I've shown you before, you can save in many different, there's Haas here, and many others. But what I do, and I find it very successful, even Roland, is just go to the, with CNC routers and most milling machines actually, they understand standard G code. Now this is the standard G code, so in our case it's G code millimeter tap. So if you're unsure what your machine will understand, it should understand this one. And save. Quite a large file, that. So what you do to move these around, you highlight and just use the arrows to move it around. So now we will move to the CNC machine and set the material up, and that will be the end of this video. And then the second video, I'll show you the entire machining operation of this eagle on my large CNC router. Right, so this is my custom built 6012 CNC router. I say custom built because it's built to my specifications. The whole gantry is one cast aluminium part. It's got linear square rails on all axes, and it has a solid cast iron bed frame. So it's a bit of a rare beast. So you've heard me talk a lot about the machine home. Well, the position where this rotor head or spindle is at the moment, which is right over this corner here. Okay, so it's as far as it can come forward safely, and as far as it can come over this way safely when it hits the limit switches, and as far up in the Z that it can be. That is the machine home position. Now the work offset, or the G54, and what you set in Carveco when you first open the program to set the size up of your material, and you select either one of the corners or the center, that's the G54, or the work offset. And it just means is that the start of the program, or the start of the machining, is offset from the home position. It's over here. So it just gives the computer, not really the machine, because the machine's a bit dumb, it doesn't think really for itself. It's the computer that does all the thinking, that runs the the actual machine. So you're telling the computer, well, the spindle is in the home position, the machine is in the home position because you've just set the machine into the home position, and I'll do that right now actually. So we'll just move this away and we'll ask the machine to go to its machine home. Okay, so what I'm going to do now is just press one button in Mark 3 and tell it to go to its machine home position, and this is what it'll do. So there you are, it's at its home position. So now I'll just move the gantry, that's this section, and the router head, the spindle. I'll just move this out of the way now, and we'll set this on the table. Right, so what I normally do, now I've got, this is a wasteboard. Now underneath here, there's an aluminium bed with T-slots in, and over the years I only use that for specific jobs, if I've got a very large job. But for smaller jobs, I just use this wasteboard and screw directly into it. And maybe once a year I'll change this top layer of the spall board, and it works very well for me. And on here I've got lines already drawn, very faint, so I know that this now is perfectly lined up with the front edge of this, and it really doesn't matter laterally where it is, because we're going to set the 0, 0 or the work off start of the program, G54. But first we're going to screw this to the wasteboard. Okay, so to find the center of the material, easy process, just draw a small line, just you put your measuring device from corner to corner, you just simply do this. Oh, a little bit longer perhaps. You simply draw a line in the middle there and draw another line in the middle there, and that gives you the center of our material. Okay, now I've got I got a small V-bit there actually. It's quite a pointy tool. Now we're going to set the X, Y, 0, 0 position on this piece of work now. So we'll just bring it in quietly. It doesn't have to be sort of touching the material or anything like that, but I just need it to be sort of close so I can see. Within, you know, ½ millimeter is absolutely fine. So Y, X, back a little bit with the Y. I'm happy with that point is as close to into the center of that X, or the center of the material, which is the point where we set the orientation of the start of the program, the G54. And in Mark 3 we just simply come here to the X0, Y0, so that has set the XY0, or the orientation of the program. So I hope you've liked that first video with Carveco and setting the machine up initially. We'll set the Z height when we come back in the next video to do the machining in two operations, the roughing and the finishing cut. So I hope you've enjoyed this video, and please press like and subscribe, and if you would like, also pop along to my Patreon page where you could support me there if you so wish, because this now is my full-time job. So thank you for joining me, and it's bye for now.